Let's take a look at finding mean, median, and mode from a frequency distribution table. Okay, so in this case, every year the students at a school are given a musical aptitude test that rates them from 0, no musical aptitude, to 5, high musical aptitude. This year's results were, now this is a frequency distribution test, so there were 5 students that got a 0 aptitude score. Nobody got a 3 aptitude. 6 people got a 5 aptitude, etc. We want to find the mean, median, and mode of this type of data set. Now the easiest would be the mode. The mode, so let me drop this down, is the most frequent. The most common. Well, obviously, the biggest frequency is 6. So the biggest score, the most frequent score, is 5. So the mode is very easy from a frequency distribution table. But the mean and median are not so easy. One choice you have, which might or might not be efficient, is to actually write down the scores. So there are 5 zeros. So let's write them down. There were 2 ones, 3 twos. There were no 3s. There were 3 4s. And there were 6 5s. If there's not that big of a data set, it's not too bad to do. We can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 students. So 19 students were given this test. So our mean will have a divide by 19 on it. So for our mean, we can add them all up. And divide by 19. So by listing all the numbers, and I'm not doing it this way just because it's not very efficient with a frequency distribution table, but we could just add them all up and divide by the total of 19. But they're giving us a frequency distribution table, so it's important to be able to find the mean using the data given rather than having to write them all down. Because imagine if they gave this test to everyone in one of the larger high schools in Salt Lake City. Now we're looking at 1,000, 2,000, 3,000 people. We don't want to list them all down. We're grateful that somebody had already summarized it down to this size of a table where there's only 6 different scores. So how would we do it? If I were to add these all up, notice that, for example, with the 2s, I'd have 2 plus 2 plus 2, but that can be written as 2 times 3. And we have those numbers right here. So if we multiply the score by the frequency, we will get the sum of those scores. So for the mean, it would be easier to do score of 0. Let's do the frequency first. 5 times 0 plus 2 times 1 plus 3 times 2 plus 0 times 3 plus 3 times 4 plus 6 times 5. That will be the grand total sum of all of these numbers. And then if we add the frequency numbers together, what will happen? There we go. Try again. 5 plus 2 plus 3 plus 0 plus 3 plus 6. We will get 19. We'll get the same that we did before by adding all the individuals up. So what we have here, it's 50 divided by 19. Try 50 again. Which is approximately 2.6. Okay, so the mean is something we can do by listing all of the scores out And if you freak out on an exam, go ahead and list them all. They probably won't be that many. And if there are, then you want to figure out how to do it with a frequency distribution table instead, which is a little more efficient. You don't have to write it all down. Now the median. So we determined there were 19 total scores. Half of that, 9. So there's 9 on the left, 9 on the right, and the one middle that we're after. That would be the 19 scores. So there is one number right in the middle, and it's the 10th one. So we're talking about 19, 9 on the left, 9 on the right, 1 in the middle. That makes 19. So we want to go 9, 10. The 10th one in should be the median. 5, 6, 7, 8, 9, 10. The 10th one will be a 2. Okay. We now have the mean is 2.6, the median is 2, and the mode is 5. Go ahead and pause this video while you work on the problem on the right. The answers you should get: 2.6, 3, and 4. All right, I hope this helps.